Okay. Hi, everyone. My name is Ahmad. I am a statistician in the Evidera team at Thermo Fisher Scientific. Today, with my supervisor, Connor, we are talking about multi-level unanchored method regression, or mlumr. We introduce its methodology and the R package that we developed for implementing these new methods. So what's the problem? As we know, in HTA, we often require relative effects of different treatments, more than 2 treatments usually. And these treatments are not often being compared in just one trial. Therefore, to solve this problem, we rely on creating a network of treatments and anchor the different treatments using common comparators. We can, as we know, we have unadjusted population, unadjusted methods like NMA, and then we can go to the other population adjusted methods like STC, MAIC, and mlNMR. The good thing about these methods are that the within trial randomization is preserved, but in some occasions, like which is fairly common in oncology and rare disease submissions, we don't have any shared arm or treatment because we have single arm trials or trials without any common comparators. The only solution is for these situations, if we want to compare treatments, is to use unanchored population adjusted methods, but these methods come with a huge caveat, and it's that it relies on conditional constancy of absolute effect assumption. It means that we must capture and adjust for every prognostic factor and effect modifiers. This is strong and often untestable. And in HTA settings, we usually have IPD data of our index trial, but only have aggregated data for the comparators. Therefore, there is an asymmetry of information, and mlumr wants to solve this problem that we will be discussing in the next few slides. We have some existing methods for unanchored comparisons like MAIC and STC. These are pragmatic, but comes with several limitations. As you can see in this table, that has been derived from the recently published paper of mlumr that you can download it on arXiv by scanning the QR code on bottom right. You can see these limitations. We cannot have a joint likelihood, including or treatment studies and subgroups in STC and MAIC. We cannot handle multiple comparators and studies. And also, we are typically limited to transport to only comparator population. This is important because in HTA, we are interested in the index population and not the comparator population. mlumr expands mlNMR regression and integration framework to unanchored settings. So let's talk a little bit about methodology. As we discussed, we have all the data for our IPD trial, but for the comparators, we only have points. Like if we have mean age, we have just this line. The red one is just a mean, and this is the normal distribution for that mean. And in terms of the outcome, we can adjust the full GLM on our IPD data, but we only have 1 point in that space for the comparator. Just like similar to STC, we can have the GLM on the IPD data. And by the way, this example is for binomial, but it's extendable to all kinds of families, and we have done that in the package too. We adjust, just like STC, we provide an individual GLM on IPD, And then the additional step compared to STC is that the comparator summary is matched to the integral of that model over its covariates. How we do that, we use quasi-Monte Carlo integration points using Sobol sequence. And if we have more than two covariates, we use a Gaussian copula and then match that to the reported moment. And then effect will be simply the contrast of intercepts standardized to that population. This way, the aggregation bias is also relaxed, which can be seen in the usual conventional STC and MAIC. We have two types of models in mlumr. We can assume that the prognostic factors across treatments share just one beta factor. This way, the model will be simpler and requires no additional data. But we also can assume that the betas are different across treatments, across index and comparators. This is more flexible, but comparator side coefficient may be weakly identified, and therefore subgroup data or sensitivity analysis may be required. And if you want to read more on methodology, read the preprint. You can, as I said, you can, this QR code goes directly to the paper, and this also have some more resources that are being discussed in this presentation. Now let's move on to the package itself. The first version, which is version 0.10, has been released on CRAN in previous months, but you can install the next version, which is version 0.20, using GitHub or by scanning this QR code, and then you load the package. We have 5 steps of analysis. First of all, you should set the IPD and AGD, as you can see in here, and then combine them. Then you add integration points to that combined data set. The default number of integration points is 64, and then you should assign a distribution to each of the covariates. And then you feed the mlumr model. In here, as you can see, for model, you can select either SPFA or relaxed, and then you extract the effects using marginal effects, conditional effects, or just use summary function in R. As you may have, some of these names are similar to multi-NMA package. That is intentional because we didn't want to introduce new names in order to make it more easier for the end user to use the package. But we also have other functions like benchmark that we have implemented naive and also STC using G computation in the package for benchmark. And then let's discuss a worked example. If you have seen the vignette of multi-NMA package, it comes with an example of plaque psoriasis. This is a connected network, but here we just wanted to assume that it's disconnected. We have a treatment from UNCOVER-2 trial, and the aggregated data is from fixture trial. And then we adjust for age, PSA, weight, and previous systemic disease. Just like we discussed before, we set the IPD, and then we set the AGD, which we should also provide covariate means, SDs, covariate types, and then we combine them and then add integration. And as discussed, we need to provide the distribution for each of the covariates. And then for benchmark, we also have done a naive comparison, STC, and fit an SPFA model on it. And then we extract the marginal effect using marginal effect function. Here in this forest plot, you can see that the naive model is more likely to be null, but for STC and mlumr, SPFA, you can see that they are not towards an all as much as naive model. And then for mlumr relax, as you can see, the confidence intervals are wide. That can be a good question why it's wide for the question period, but the answer is that if we transport to the index population, we usually need more data because we only have one age aggregated data point. And then what about how the elements that we can extract from the model?
Apologies,
If we
Ahmad.
run summary function, you can see we have a model summary in here, like model family. And also,
Ahmad,
you
can I
can
just
also
interrupt
select
you? Sorry,
engine.
just
The
1
default is
second.
RSAN, but you can also use SAN R. And then NCMC diagnostics, the regression model, coefficients and everything, and then marginal effects in both populations, both index and comparator, and it
Ahmad, can you hear
differs
me?
for each of the families. For binary outcome, is that's the case in
Ahmad,
here. We
Ahmad,
have
can you hear
log
me?
odds, risk difference, and risk ratio.
Ahmad,
And
can you hear
then
me?
this is previously we discussed marginal effects, but here we also can have conditional effects for a new population with age of, for example, 40, BSA of 0.15, weight of 7.5, and previous systemic disease of 0%. And here in the first profile, you can see the results for that population, and we have two
Ahmad,
other
Ahmad,
profiles
can
in
I
here,
ask
and
you
you can
to
see
stop for a
the
second
others
because we
in
can't hear you
here.
properly?
If you want to extract absolute outcomes, you can use predict function. And
Ahmad, can you hear me? I don't think your audio is
we
okay.
continue.
Yeah, there must be something wrong with your audio and probably your computer because you were not hearing me. Can you hear me
Yes,
now?
I will
Can you hear
disconnect.
me?
Can you? Yeah,
Can you hear me?
I
Can
cannot
you hear
hear
me,
you.
Ahmad? Okay. We'll write. I think you probably need to log on again, log off and log on again. Ahmad, can you hear me?
Sorry.
Can you hear me now?
Yeah.
Okay, okay. We try to stop you because your audio is not of good quality. So we've missed what you said in the last couple of slides. Would you mind sorting up your audio because the quality is not good at all. Probably that's why you were not hearing us when I tried to interrupt. Yeah, it might be a battery problem as one of our attendees is
Uh,
okay.
is my audio quality okay now? Okay.
Yes, much,
So,
much better.
Much
Yes.
better. Yeah.
Thank you.
I'm sorry for that thing. Yeah, that was a problem with my AirPods. So, I think I need to start
Yeah,
from.
from probably the previous one. Yes, from here. Yeah, I think that's better. Okay, good.
Thank you very much, and sorry for that. We have I was talking about a worked example that it's the PASI 75 in plaque psoriasis. It's in a vignette of multi-enemy package that is a connected network, but here we assume that it is a disconnected network between two trials, uncover two and fixture trial, and we adjust for age, BSA, weight, and systemic disease. As discussed before, we have 5 steps, setting the IPD, setting the AGD, and we provide the outcome, covariate means, standard deviations, and covariate types. And as you can see, for binary outcome, we don't have standard deviations, so it's just covariate mean. And then we combine these and add integration. For integration, we need to define a distribution for each of the covariates that you want to adjust for. And then we also provide two types of benchmarks, naive, which is unadjusted, and STC. And at the end, we fit the model. Here, as you can see, we also can set the prior information, prior distribution that you want to use, which default is paranormal with mean of 0 and SD of 2.5 and 4 chains, 2,000 iterations, and of these 1,000 is for warm-up, and then seed and everything. And then we extract the data using the marginal effect. In this forest plot, you can see the results for all the benchmark and the fitted model of mlumr. As you can see,
Sorry, the slides are not showing anymore. Can you reshare?
You cannot see my slide?
Yeah,
it's moving having a problem now. Okay, cool. Thank
we
you.
can see them, yes. Thanks, Ahmad. You can carry on.
Okay. And in here, as you can see, the naive is more towards the null, whereas STC and mlumr are away from the null. And as you can see, the confidence intervals for mlumr is narrower compared to STC. And for a relaxed model, as you can see, the model is unstable. The reason is that we only have one data point from the aggregated data. And if you want to transport it to the index trial, we don't have sufficient data. That was discussed previously, and that for relaxed model, we typically need more data if we want to transport it to index trial. Let's discuss some other outputs. If we run summary on the fitted model, we can see different sections about the fitted model, like the summary of what type of model was that, the link function, and also engine. We can use rstan, which is the default, or command stan R as a sometimes it's faster than rstan, and also we can see the MCMC diagnostics, the regression model coefficients, and at the end the marginal effects in both populations, in index and comparator. This section is different for each type of families. For binary outcomes, it's log odds ratio, risk difference, and risk ratios, but obviously for survival it's different. For example, for continuous is mean difference, and so on. And in here, previously we discussed marginal effects, but we can also have conditional effects. And we introduce new data. For example, in the first profile we have introduced 3 profiles, but for the first one, the age, we set the age as 40, the BSA 0.15, weight 7.5, and previous systemic disease of 0. And as you can see, we can have the mean, SD, and quantiles in here. If we are interested in absolute outcomes, we can use predict function and then pass the model to it, and the population will in here is indexed, but it can do the same in the comparator population, and then we can have the absolute effect. And for benchmark, you can just easily use STC over the combined data, and or naive, and it gives you the results of the STC, as you can see in here. We also introduced plots in version 0.20. Previously, the user needed to use ggplot or base R plots in order to plot the outputs of the mlumr, but in newer version, you can use simply plot function, and if, for example, you use plot over marginal effects, you can see all these forest plots in both comparator and outcome, comparator and index trials, because we have set the default is in both populations, but you can also see the forest plots in just one function or just one effect, and as you can see, the effect is all in here. And if you want to have absolute outcomes in the population and per treatment, you can use plot predict and put the fit in here, and then you can have the absolute outcomes in each of the population and each of the treatment arms. What about time to event analysis? The good news is that we have that now in version 0.20. The only difference, everything is the same. The only difference is that we have a new function set AGD serve. And in that function, the user needs to provide a pseudo IPD that is reconstructed from digitized KM curve. And you can select from one of the 9 parametric forms or splines in order to do the survival mlumr, and then extract information on survival like HR, RMST, hazard, or median. And this is the survival mlumr from one based on the data from the survival vignette of mlumr. And then next steps. As we discussed in current version, we have SPFA and relax models for 3 types of outcome families. And we have HTA ready set of functions for estimating effects, predictions, benchmark, and so on. In the newer version that will be introduced shortly, like in a week or so, we introduced time to event families, 9 parametric ones, and also M-spline and piecewise exponential baselines. We also have native plotting system and also transport to any target population other than index and comparator. In 2 minor version, after version 0.2, we have 3 minor versions that introduce 3 new methods to speed up survival mlumr. If you have worked with multi-enemy package, survival, MLNMR, and also mlumr takes sometimes more than a day, and it's a very heavy computation. But we have reached 3 types of speed up systems: arm-fast, tie aggregation, and alternative integration methods that can speed up the survival, especially the splines, like 2 or 3 times faster than the current speed. And the next version, which will be in version 0.30, it will be a major release and will extend the current 2 ARM to K treatment networks, disconnected network more than 2 arms. And then finally, in version 0.40, we introduce quantitative bias analysis specific to unanchored ITCs. And thank you. But before we start the question period, I want to introduce a browser app, mlumr Playground. You can scan that QR code. It doesn't require R or anything. It doesn't require any server. It just sits on your browser, and you can try different methods and different families simply on your browser. Thank you very much.
Thanks very much, Ahmad. And let's leave that page so people can scan that QR code. Unfortunately, given the technical difficulties, I'm going to reduce the discussion to 1 question, and we do have one from Howard. Howard, I don't know if you want to vocalize your question. I can see that you sort of obtained the answer from your last comment, but probably a bit of a discussion that would be great.
Yeah, so Ahmed, thanks, great work. I was just asking about unmeasured confounders because it's obviously a greater risk for the unanchored comparisons because you need to include both prognostic and effect modifiers. So your last bullet was saying that you're going to implement QBA. So I'm just curious what your plans are for that.
We for QBA right now, we are extending, if I'm not sure, but there is a paper on QBA for an anchor comparison by Iran in 2025, I think. We have extended that framework to include probabilistic QBA and also E-values and tipping point analysis. Currently, we are thinking about just implementing that for now, but we will shortly thinking about implementing more methods or developing new methods for specific to unanchored comparisons.
Sounds good.
Excellent. Thank you very much. So if you have any more questions for Ahmad, he can answer back. So put them in the chat and he can answer back to them. And